Hi, I'm Rick Sellens. I'm your instructor for MECH 241, your first fluid mechanics course. Some of you will remember me from MECH 217, where we talked about measurement. Now we're moving on to look at some of the fluid mechanics that requires us to understand things like pressure and temperature and motion in fluids. In this course, we're going to focus on fluid mechanics from an F equals ma physics sort of point of view, looking at motion and the forces that cause it. This is the same whether you're working with fluids or solids, no matter what the environment you're working in, and we'll try to bridge that gap between the two.
As you might have guessed, I've been doing this kind of thing for a long time. I got a Bachelor of Applied Science in 1981 from another university, not Queen's, that had a co-op program. So I've had an industry focus just about all my career. Right after my bachelor's degree, I went out to Alberta and worked in the oil patch, designing heat exchange equipment and looking after actual fabrication for installation. I went back and did a master's and a PhD in fluid mechanics and combustion and applied that knowledge to go on and do postdoctoral work in Germany at the Lehrstuhl für Strömungsmechanik at the University of Erlangen, where, among other things, I worked with the European Space Agency on figuring out why the rocket engine, the third stage booster in the Ariane 4, didn't light on at least one important occasion. We did a lot of interesting measurements at very high speeds for that, because the whole ignition process for a rocket engine is all over in about 250 milliseconds.
My own particular interest started off with the atomization of liquids into sprays. This is something that has to happen in just about every combustion situation where you're burning a liquid fuel, whether it's something as pedestrian as a diesel car or something as exciting as a liquid hydrogen, liquid oxygen rocket engine in a spacecraft. That's why you may hear me talking a little bit more about surface tension forces, because surface tension forces are absolutely critical in breaking up liquids into very small drops. They're not all that important to most other engineering applications, so they're the sort of thing you just want to keep in the back of your mind.
From Germany, I came to Queen's, where I've been teaching in mechanical and materials engineering for over 30 years. I've taught a wide variety of courses, mostly around fluid mechanics, design, measurement, and a really interesting course that we put on some time ago on spacecraft systems design, which again involved quite a bit of measurement and drew on my experience from ESA.
I'm a keen racing sailor. I really like sailboats that go fast. And there's nothing that gets the last tenth of a knot of speed out of a boat like optimizing the fluid mechanics of the flow over the hull, over the foils, and around the wings, the sails of the boat. So I use fluid mechanics a fair bit in my hobbies as well as in my academic work. Fall of 2020 was a real challenge, trying to hit the ground running and deliver remote course material, particularly in a lab course. This MECH 241 offering is something we designed from the ground up to be an online course and that we've given multiple times before. So I'm really hoping that this winter term 2021 will go a lot more smoothly for you and keep your stress levels down and manageable. I'm really looking forward to a good term and working with you to get through the basics of fluid mechanics so that you can understand how to do simple mechanical engineering applications that involve moving fluids like water and air around.